Welcome everybody to the second installment of Keysoft's Landscape Architecture Design Solutions webinar series, where we're helping firms learn how evolving technology can solve some of landscape architecture's biggest design challenges. I'm Mike Schumann, Vice President of Sales for Keysoft Solutions, and I'm joined today by Nate Qualls, our Product Support Lead here at Keysoft in Boston, Massachusetts. In today's webinar, we're going to be discussing a hot topic of discussion in the industry, and that's lots and lots of landscape architects are being pushed into Revit, a tool not built for landscape architects. Now Nate's going to share how you can increase productivity and reduce integration errors by avoiding the Revit workarounds landscape architects are often forced to use both inside and outside multidisciplinary firms with Keyscape LandCAD's export to Revit feature. This feature enables landscape architects to work quickly and accurately in the familiar AutoCAD environment while allowing them to contribute to a BIM model while significantly improving their workflow when engaging with architects using Revit. Nate?
Thanks, Mike. In the next half an hour or 40 minutes or so, I'd like to cover four big topics. First being what we're hearing from the market today. Is Revit the future for landscape architects? What misconceptions are present today regarding Revit and the current state of BIM for landscape architects? What we have learned and developed from our experience in the UK. And we'll show how one of our customers is achieving BIM compliance using a combination of Keyscape and exporting to Revit for their architects to include in their modeling. So topic one, is Revit the future? At ASLA this year, we talked to a ton of people wandering through the expo. And one of the phrases we kept hearing over and over was, I'm being forced into Revit, I don't know what to do. Can you guys help, or do you have a solution? And we were curious to find out, where this mandate was coming from. Why were they being asked to move to Revit? And the answers we got back from them are, could it be municipalities or jurisdictions that are requiring deliverables in a certain format? Was it a prime consultant or the client or owner requiring deliverables in a certain format? Was it leadership within the firm pushing for what they perceived as the future of design software? Or was it a multidisciplinary firm where normally it's a majority architect type of firm and they want all the designers to work on the same platform? Most of the time it was the last two options. It was either leadership looking to future-proof the firm, maybe not quite grasping exactly what BIM was all about, or if there was other options besides molding Revit to their needs. Or it was a firm where there could be 20 architects, 20 civil engineers, maybe only 5 landscape architects, and those 5 landscape architects are being pushed to come on board with a platform that's really not built for them. And we understand that it's not out of spite or anything that we've been seeing people being recommended to move to Revit. It's the fear that BIM, building information modeling, is coming soon, and landscape architects are about to be left behind. The misconception here is that Revit is the only way to become BIM compliant. And Autodesk has made it very clear to us that as an Autodesk partner, we talk to them quite a bit. The LA market, the landscape architecture market, is really just too small for them to address with dedicated tools. That leaves developers like Keysoft to develop tools, or for firms to try to develop software in-house. And just so you know, that's the team right there. So let's talk about Revit a little bit. There's some good things and there's some bad things. Revit is good for general quantities and attaching data to objects. But for landscape architects, you have to set up this customization and modify objects one by one. There's little automation in the LA's scope of work. It does enable parametric design for buildings and structural components, which is great for architects and structural engineers, but there's only rudimentary site design capability embedded. Autodesk developed the site tools within Revit as more of a graphic tool for architects to visualize the buildings with a bit of a background for context and illustration. It's not necessarily intended to be an accurate, quantifiable model for things such as cut and fill. But some people are willing to sacrifice these weaknesses for the advantage of working in a native Revit environment. Speaking more about the external works, site works, plant areas must be created as a floor. You have to use terminology and tools that were built for the architecture and structural environment and twist those in ways to get results. You can't attach data to a topo surface, and there's no real ability to address planting revisions globally. You're kind of changing things one at a time within Revit. Cut and fill calculations are possible with some a little advanced programming. It is tedious. Same thing with ground modeling. You can get their topo surface to work to your will, but it's going to take a lot of work to get little result. Another thing we hear is regarding the geo-referenced nature of a lot of our projects. We get surveys from surveyors or civil engineers, and those are usually drawn on real-world coordinates. Revit doesn't handle that well, so certain scale of projects, such as master plan communities or large corporate campus projects, might not be well suited for Revit either. And then, a few other questions that I ask when I'm assessing any technology, whether that is, CAD software or accounting software or anything. It's will it allow me to take on more projects per year? Can I complete those projects faster? Will it allow me to focus on my core competency, which is landscape architecture and design, winning back design time? And will it give my designers time back? Will it make their job easier and more enjoyable and retain talent? So let's dive into what BIM is and isn't. So this is a traditional project workflow. It's very familiar. We start off getting a briefing, getting a request for a proposal, or submitting a proposal. Then the second step would be design. That's where the bulk of our billable hours would come in. And then a little bit of construction administration, and then you just hand the project off. So many principles of a BIM workflow are probably already being practiced in your office. You probably have a server location that's hosting CAD standards such as title blocks, text styles, symbols, your detail library, other office standards such as your specification documents, cost estimate information, site inspection forms, and this is all hosted in a central location. There's probably another location that has all of your project files in a central space. And then you also have some sort of process in place to ensure that all of your designers are all working on the latest and greatest base information and the latest design revision. And you may have even put together a document or a binder that has how to do a project at my firm. And you can hand this off to a new designer or project manager, and this kind of guides them through your way of doing things. The difference between the traditional project and the BIM project is that this level of organization is extended across the entire design team, all the consultants, anyone that might contribute, including suppliers and vendors. And it also applies to the entire project timeline, not just the design phase. So from entitlements and proposal phase work all the way through construction, project handover, and project maintenance even. So we do some of this stuff already, but we do it in a siloed environment within our own firm. The challenge is to put in place a BIM execution plan that unifies all the different trades. A BIM execution plan is a document comprised of three factors: roles, responsibilities, and deliverables. And how you go about these three factors is up to the owner of the project and the team members. But the main goal here is to answer the question, are we going to deliver this within a framework, or how are we going to deliver this project in a framework of a certain budget and a certain time? And this is done through setting standards such as data drops, key points or milestones where data is pulled together to check, are we on budget, are we on time, are we meeting the program requirements of this project? We also set protocols, so standards such as units, base points, and a schedule to update our common design environment. We need to set up a schedule to test the model. This needs to happen early and at a set interval. This helps us keep a handle on cost estimation, logistics, and really it helps prototype the project earlier in the design when changes are cheaper. We have to compare this to other trades such as the automotive industry or the fashion industry. Folks like Nike, modeling a shoe over and over again in a safe environment before moving out to the field where changes and mistakes are going to be much more costly. We also need to pull in facilities management and kind of this bottom section of the handover and management phase. Landscapes can last hundreds of years, so it's critical that the owner and his maintenance and asset managers know how to handle this and project cost for this ongoing maintenance. So the knee-jerk reaction here is to say, okay, we've landed a project with a BIM mandate. We better go buy a license of Revit. But Revit doesn't answer any of these questions for you, and just owning and using Revit doesn't make you BIM compliant. In fact, defaulting to Revit as the sole data environment could be a limiting factor based on the scope of the project and the needs of the owner. So right now, in the current state of the technology, the best bet is to each consultant use the software that's most efficient for them, and then find a way to build a model based on those. They could be different tools, but the key here is interchange formats and putting together a plan and a framework. As your office begins to form a BIM execution plan, it should reflect the needs of your typical client and your typical team of consultants. But as we know, every single project is different, and so every project needs to have a unique BIM execution plan. And we've been doing this in the UK for quite some time now. Since 2015, landscape architects in the UK have been required to achieve a certain level of BIM compliance for publicly procured projects. So that'd be the equivalent of a federal or a state level project here in the United States. And when they were trying to analyze what technology was going to be appropriate, they looked from the end backwards. So project would work starting with you identify the requirements of the program, you execute and you design, and then you deliver a CD package. When we're looking at what we need to achieve a BIM project, we need to start at the end. What is the exchange point? How are we exchanging data? What are the data formats? We look at the workflow, how we collaborate, and then we identify the gaps in our process, and that's when we would invest in software to help us fill those gaps. So this is just a quick visualization of where we are. The industry is kind of right now is the red line. We're somewhere in between level 2 and level 3. Level 1 is where we all started, just plain AutoCAD, printing out paper documents and distributing those to the builders or the contractors. Level 2 brought in a little more standardization, some 2D CAD and 3D CAD. That's where most of us are today, somewhere in level 1, level 2 area. Level 2 just really means that the standards are getting spread amongst the team members. There's a level of communication and a level of data sharing that's scheduled and programmed more extensively. Level 3, hopefully in the next few years, with data formats like IFC, that enable interchange between lots of different programs, we're going to have a lot more flexibility of how we share data and build that one model, that one source of truth model. So right now we're level 2. What is level 2? So it's 2D CAD drawings, which we already have. We have managed 3D, in the cases where it makes sense to have 3D. There's no point to doing 3D if there's not a good reason. If it's just for visualization, just for the client to understand, that's one thing. If it's needed for the asset managers or the contractors, that's another thing. But not every project might need that level of detail. And then information exchange. That's really the part that most firms are missing is how to exchange data into that federated model that's updated on a scheduled basis. So that's kind of a brief overview of what BIM is and the theory behind it. If you want to dive deeper into this, there's a book called BIM for Landscape, and it's co-authored by Mike Shilton, who's one of our product managers. He is a chair for the Landscape Institute, which is the UK's equivalent of ASLA, and their BIM committee. So he's quite the industry expert in the UK, and that book is a great starting point. There's been other few articles recently. Landscape Architecture Magazine published an article, The Limits of BIM, which is very informative. And then there's a series of articles in World Landscape Architect called Revit and Landscape Architecture. Again, I'll be posting this video online on YouTube, so if you want to jot down any of these URLs, you can always come back to that. So let's look at what Keyscape is doing, Keysoft and Keyscape LandCAD. What we have developed is a tool to export to Revit. This is the current state of the technology. Most people that are currently meeting BIM mandates are using Revit because of the lack of options and because of large industry adoption in the architecture space. So what we allow you to do is to export items such as tree specimens, shrubs, hedges, plant areas, even paving areas and pathways into the native Revit environment. And this is done through an export-import process. It's built into Keyscape LandCAD, and it's a free plugin for Revit. The other way we can contribute information to the final model is through LandXML. And LandXML is an interchange format for civil engineering design suites, but we also leverage it in Keyscape LandCAD to bring in and out surface models, contours, even some drainage structures, and those kind of subsurface utilities. We can bring those into Revit as well and produce a much more accurate topo surface than what Revit can do on its own. So let's dive into a demonstration here. This is what you would typically see on the architect's side of things. We may have already sent them a topo surface. Their building footprint is placed on it, kind of in an arbitrary location. We can help them cite that as we move forward. But what they're going to do is send us a floor plan of that building. And that's really all that we care about in most cases. Maybe in some projects we might want to see more of the facade, more of the first floor plan to see where the egress points are. But what they're doing here is they're taking a DWG snapshot of that floor plan, and we bring it into Keyscape. And so we have the outline, maybe the roof line in this case. And what we've done is we cited that building. We've added a drive, a walkway. We can begin to add plant material. And this is all Keyscape LandCAD interface here. We're adding specification information to the plant material, so that they're not just symbols. It's symbols tied with specifications. And that fulfills a BIM requirement, the level 2 requirement that's needed in the UK. So we can choose items like height, pot size, girth, caliper, anything that might be needed to specify that plant from the nursery, or to get the design intent across to the installers. So let's place a few trees in here. Let's place one more over on this side and click OK. And now I'm not placing a label at this point, but inherently those objects contain that data. We can also add paving areas, edging, pathways. So here I just want to select this path down to this pond, and let's say that it's just a crushed granite or decomposed granite pathway. This could be anything we want to. It could be brick or concrete unit pavers or concrete. The paving tool is just a great way to get quantity takeoffs, cost estimation, and ultimately specifications to the contractor or to your architect partners. So I'm going to jump forward a little bit here to where we've taken this project a bit further, added plant areas, we've added hedges. Again, if I double click on one of these areas, you're going to see all the information tied to it. So that this is a mix of species in that hedge area. Same thing with this plant area, these beds. We've got some single species, some mix of species, so very complex specification. We want to get that out to Revit. And why we want to get out to Revit, it can be as varied as the number of projects you take on. It might just be for visualization reasons, for the architect to create a rendering that actually has an accurate topo surface and an accurate planting design in it. Or it might be to get the actual specification into Revit so that quantities can be established, so that analysis can be done on the building, photo shadows, and other subsurface studies can be done. What I'm doing here is establishing the shared coordinate point. So I was working in real-world coordinates based on the survey I got. The architect's working closer to the 0, 0 coordinate in Revit because of the Revit's limitation. So I just need to communicate a bit with my architect consultant and establish where that point is. Now I'm exporting a KXR file that has all my plant material and all my paving areas in it. And you could pare it down as well. Just the same way that we only brought in the architect's footprint. They might only need our large shade trees. They might not need every single perennial bed or every single small shrub. They might just need what really affects the building from a shade perspective. And then again, that's all established in your BIM execution plan and what deliverable you need to give the client at the end of the design process. So here I'm again selecting what I want to bring in. That's processing. It takes a second to build out the families and associate all the specification data with those families. And now we have plant material and paving areas in the design. If we go into the 3D view, we have this data as is, which is powerful because it's been accounted for in the project and we can analyze it if we need to. Let's click on a few of these objects. You can see they have root balls tied to the trees. If you do have your subsurface utilities modeled, you can do clash detection there. You can see we brought in the labels, which I probably would have turned these off just because this information is redundant. It's already tagged through attributes with these families and symbols. And so it's a great tool as it is here. But another thing that you can do is use Revit for visualization. And you're free to move around the objects once they're in. So if you need to adjust elevations, if you want to place plant material on a roof deck, those changes can all be made in Revit as well. But we know that right now the XY coordinates are accurate, the size is accurate, the specification is accurate, just as we designed it in Keyscape. So here I'm going to swap out our little lollipop symbol with a more complex, almost photoreal symbol. You could purchase these libraries through multiple of vendors. I believe this one's called RPC. And that's one of our existing lollipop trees. You can see it has a root ball that's dynamic. And it has the data tied to it. Let's just reposition here. There we go. And you can see all the possible properties that can be associated with that plant material. It's also great for indicating, trees to be preserved and annotating attributes like that. So let's say that we want to use this not just for analysis purposes, but also for visualization purposes. Let's do a quick rendering. We swapped out some realistic trees, and now we can do a quick snapshot. So you can see that the realistic trees, this background is a little bit blurry, but you get the point here. And then over on the right here in the project browser, again, you can see this planting family and all the information that's been brought in. So it's all quantifiable now, and it's all accurate to what we had intended to be built. So that's where we are today. So we're able to bring in paving areas, we're able to bring in trees in 3D, and we're able to quantify those kind of things. We can also bring in surface models and propose or existing conditions. What we're looking forward to in the spring of 2017 is additional Keyscape objects, things such as site furniture, irrigation components such as piping and heads and valves, looking at walls and adding thicknesses to paving areas, so subsurface conditions and subbase courses, bringing those in. We're also currently developing the ability to export to IFC. And what that's going to unlock is the ability to bring your data into any BIM environment. That's the international interchange format. It's open source. Any BIM software that you do consider, if it doesn't accept IFC, I would strongly advise against that, because that looks like probably the future of BIM interoperability. Now let's look at a quick case study of what one of our clients, customers, SLR Group, and how they use Keyscape and Revit together to achieve a higher level of detail, how to, they also optimize their workflow when engaging with architects using Revit. And these guys are no joke. They are a global environmental and advisory solutions provider in North America, Asia, Africa, and Europe. They have, their scope extends from environmental through engineering, through architecture, but most applicable here, they have offices that focus on planning, landscape architecture, master planning, and urban design. So the way they use Keyscape LandCAD is to design in 2D and to automatically get a 3D output based on the tools that Keyscape LandCAD has in the native AutoCAD environment. So these are planting areas, we have some hedgerows, we have some specimen trees. And this is a very clear plan for a contractor to build from, but the architect also wants to analyze the site, the effect on the building that the trees will have, and also generate a rendering so that the client and the other stakeholders can understand the implications of some of the design decisions we've made. So again, step one, we're exporting into Revit. Their architecture partners have adopted our free import tool, which is just a plugin, very small program that reads our file format. Again, this will be probably mostly surpassed when IFC interchange is available this spring. And then they're able to add or manipulate any of the specification data within Revit. Analysis and quantification can be done within the Revit environment if need be. In this case, the impetus was to mostly create a rendering that included the Revit model. So you can see this is a bit of an urban project. We have placed all of the plant material on the topo surface and the green spaces in between the paving areas. We've replaced the lollipop kind of trees and the more generic ground cover symbols for their photorealistic library that they've purchased. And then when combined with their architect's model, you really get a full picture of what the site is going to look like. We know this is aligned with the design intent that was laid out within Keyscape. It's a high level of accuracy, a high level of quantification here, and it's not just a pretty picture anymore. It's a constructible project. So in summary, a few key takeaways here. Is Revit the future for landscape architecture? From what we've seen, what we've talked to people at the ASLA conference, we don't believe it's there in its current state. It requires a lot of customization and a lot of workarounds, and that puts a big hit on efficiency and workflows that we are accustomed to. Autodesk, again, is not coming to the rescue in this front. Landscape architecture is too small of a market for them to address, and that's why they've encouraged Keysoft Solutions to continue to develop tools like this, tools that are developed specifically for landscape architects from a firm that's focused on that community. The current state of BIM, we talked about a bit, that it's not necessarily a single software solution. There's no single software that's there that can cover all the trades yet. And BIM really is a process and a communication channel, not a piece of technology. Unification around a single project is not necessary or efficient at this point. We talked a little bit about what we're doing, where we're at with Keyscape LandCAD, where we're going with IFC and other interchange formats, and adding more objects to our list of exportable families. And then we looked a little bit at SLR and how they have gone through this evolutionary process. They found a workflow that works for them right now. It makes them BIM Level 2 compliant in the UK, and they're prepared to make the next steps for BIM Level 3. And they've partnered with Keysoft as we move this project forward and as we continue to work hand in hand with partners such as SLR to develop this product. With that being said, I'll hand it back over to Mike to wrap us up and close us out.
Well, thanks, Nate. That was terrific. Really appreciate you taking the time to pull that all together. And we want to thank you for attending today's webinar. Hopefully, we've shown you how Keyscape LandCAD can help you and your teams work quickly and accurately in a familiar AutoCAD environment while allowing them to contribute to a BIM model while significantly improving their workflow when engaging with architects using Revit. Look for an invitation to next month's webinar. On behalf of myself, Nate, and the entire Keysoft team, thanks again.